Hi everyone, welcome back to Math Tutoring. Today I'm going to do a quick video on how to find domain for functions step by step. So pretty much in order to find domain, we're going to split up all the types of functions you'll come across, all types of graphs. So first case are polynomials. So polynomials are just curves that have combinations of these powers, right? So you know, see these are whole positive powers, 1, 2, 3, 4, 5, right? That's a polynomial, okay? So the good thing about polynomials is there are no restrictions. So the domain is always going to be all real x if all the x terms have positive whole powers, right? Because what we're going to do in order to work out domain is we need to think restrictions. So that's the key in order to work out the domain for each type of function. So now square roots. So this is the, right, because for polynomials there's no restrictions for subbing x values into positive whole powers. Now when we're dealing with square roots, so something with a square root and there's a function inside the square root, we have a restriction now. We can't square root negative numbers. So what we do is set inside greater than or equal to 0 and solve for x. Okay. So that's how we find the domain for a square root function, right? We just think, what's the restriction? Well, we can't square root negative numbers, so the inside has to be 0 or greater than. So what I mean by inside, it's everything that's underneath the square root, and you create an inequality equation where you have to make x the subject to get the domain. Now hyperbola. So hyperbola is anything where we have x's in a fraction, right? So the restriction is when we have fractions, we can't have 0 on the bottom. So basically it's going to be all real x, and x can't equal what makes the bottom 0. So what that means is set bottom to 0 and solve. Right, so you're going to have an equation or a quadratic equation to get the values of x that you can't equal. So it's going to be all real x except what makes the bottom 0. Next, logarithms. So you might have come across logarithms. So the thing with logarithms, if you've seen the curve, is you cannot log negative numbers or 0. You can only log positive numbers. So what that means is set inside to greater than 0 and solve for x. Okay. So logarithm has an extra restriction to square root. You can square root 0, but you can't log 0. It has to be strictly positive. Now we get to exponentials. So exponentials is 2 power x. So the thing about exponentials is the domain is it's going to be the domain of the power, right? Because whatever the power is its own special function. So here this is a polynomial power. So that means x falls under polynomial, so it's all real x. Based upon exponentials, whatever the power is, you class it under one of these and then find the domain of the power, and that's the domain for an exponential. So I had an example here, 2, 1 over x, that belongs to the hyperbola. So I just find the domain for 1 on x, and that will be the domain for that whole function. Last thing I want to mention are circles and semicircles, right? Now circles aren't technically functions, but we can still find the domain of circles straight away. So if we have a center, hk, radius r, the domain is just going to be h minus r less than or equal to x less than or equal to h plus r, right? So all that means is you just add the radius to the x center and subtract it, right? So x will be between those two values. And I just want to make a quick note here also, is this is a semicircle, right? So that's what a semicircle looks like. And you'll notice that that is a square root function. So if you didn't recognize this was a semicircle, you would have to go through and solve it like this way. You have to solve the quadratic inequality. But if you recognize it's a semicircle, you just straight away know, well, the center is 0, 0, and the radius is r, so then the domain would be negative r less than or equal to x less than or equal to r straight away, just by recognizing it was a semicircle. So it pays to recognize circles and semicircles, because if you try to solve it, but with the square root function method, it'll be a lot more difficult, or take a lot longer. Okay. So those are pretty much all the main functions you'll come across in high school. There are trig ones, but they deserve their own separate video. Okay, so these are the main ones besides trig functions and inverse. So these are the basic ones. So this is more at a year 11 level. These are all the ones you should come across when you're in year 11. Now, if you still need further help and you want examples, I would like to do examples for each, but to make the video a lot longer, is just comment below if you want me to do a separate video where I do an example for each case. Right? Otherwise, don't forget to like the video if you found these tips helpful. Comment below again, if you want an example video or what videos you'd like. And don't forget to subscribe. Alright, see you guys later.